With the popularity rise of text embeddings and vector databases, I decided to try to make my own search engine, well, like Google.
Cool.
Unlike other periods in time, now we have not only tools like Huggingface, text embeddings, machine learning models, vector databases like Qdrant for free that make similarity search very efficient and quite good actually compared to the results we had previously with Elasticsearch or Algolia. Now everything will be for free, and that's very easy to set up. But not only that, we also have the common crawl dataset, which is the entire internet scraped into very small chunks that we can use for free without actually spending millions of scraping entire internet, every single website content, which might end up costing us a fortune. An actual coding on this project took me less than 4 hours, but it took almost 2 weeks to process 400 gigabytes of data from Common Crawl, and that only took less than 1 million domains on an actual internet available websites. And that processing, actually what it means, I've been transferring the raw text from the Common Crawl web pages into a vectorized data, which I will explain in a second. But I understand that whoever gonna use this project from the GitHub repository, I put it publicly, they're not gonna just do that on their laptop, the entire dataset, but that's a really good exercise just to pick up the Common Crawl dataset, download that automatically with the scripts I provided in the repository. And without further ado, let's jump into more details on how I've done this process. The process of text embedding similarity search can be broken down into 3 steps. First, find the data that we want to convert into vectorized data and then perform a similarity search. Second, find pre-trained machine learning model that actually can convert the language specific vector data and understand that from the perspective of vectorized database, and then convert the search query into vector data to perform a similarity search on top of the vector database like Qdrant, which actually runs the vector-based search queries instead of a traditional text-based queries that we had previously. That's pretty simple if you understand what it means, an actual vector data. And in a nutshell, that's just an array of numbers or floating numbers where each vector is a representation of some space with the word similarities assigned to that machine learning model. The text embedding machine models are pre-trained on large amounts of text content. They have spatial vector or floating numbers mapping for each word they know and can easily predict next word, similar words we might use in our text. From coding perspective, the text embedding is a number array representing your text in some virtual space that you can think of as a 3D, as multi-dimensional space. And the cool thing about this is that those numbers are attached to a vector space where you can figure out what will be the similar text representing that vector. Unlike more traditional ways of doing search, like having an extensive dictionary of words or tagging data with similar word combination, this type of vector search is incredibly efficient. It can work on larger data sets than traditional structures like Elasticsearch or Algolia search, which of course based on the word mapping and dictionaries rather than converting things into vectorized spaces, which is very new compared to those search engines. I've used the Huggingface Text Embeddings interface project, which is the open source service developed by the Hugging Face to use their text embedding models published with the PyTorch model in them. And the good part is that the MacBook M1 GPU supports that, and we are able to execute directly on MacBook M1 Max CPU, which gives pretty good performance. But the thing is that we actually have to compile that locally in order to run it over the macOS Metal driver, which is a similar thing that NVIDIA CUDA has on Linux-based machines. But luckily Hugging Face have everything in place to use that from macOS, and compilation went pretty good. Actually, it went without errors, but it took a couple of minutes, which is just fine. For the machine learning model for text embedding, I've chosen the first one on the list in Hugging Face repository from their suggestions, but I am sure there should be different types of models based on your language and the type of things that you want your search be performed on. For example, there is multi-language models which are a bit larger and their execution takes more time, but they of course support many other languages. And there's also specific language-specific machine learning models that you can use to convert text into vectorized representation. Like you can use Chinese version, you can use English version, and each one is trained on top of the large data set on that language. So it's very efficient for language-specific tasks. Now that we have the text embeddings interface and the machine learning models, it is time to run service locally using their command line arguments. After having the text embedding interface running, now it's time to jump into Common Crawl dataset, where I decided to go with the last 6 months of crawl data, which turned out too much. Each data chunk is stored as gzip files, so we have to first download the list of files, unzip them, store in temporary files because an actual crowd text files can be more than a few hundred megabytes, and doing string operations would be super slow. Instead, I went to the implementation of Node.js streams to read file line by line using Node.js streams API instead of reading entire file into memory. After parsing the wet file format, the Common Crawl files has each line contains the content of the web page. So to vectorize that using the text embeddings, I'm cleaning from non-alphanumerical characters and breaking that to text into word-based chunks, because the text embeddings text content is limited. It has to be less than 512 tokens, and I'm safeguarding that by limiting the number of characters to 500, and depending on that length, I'm choosing the words to stick together in order to form a proper sentences to vectorize. At this point, I have the vectors, and it is time to store values in Qdrant vector database and MongoDB for later reference. Here it's essential to note that MongoDB is entirely optional. Vector database will be the primary search data storage. I'm keeping unique text chunks inside the MongoDB with the unique IDs to avoid multiple repetitions and blowing up the storage unnecessarily. Qdrant gets only MongoDB IDs to receive the final text results after we done the similarity search on the Qdrant vector database. Now that we have things in place, let's run the data worker to start visualizing and storing our dataset inside our Qdrant database and MongoDB in parallel. This process is slow, especially on your laptop, unless you have access to vast compute resources like Google and you can have thousands and thousands multiple GPUs to process parallelly. I haven't even completed the 4% of Common Crawl's latest 6-month database within 2 weeks of processing on my M1 Max GPUs. So I'm not sure if that's even comparable of having the Google's data sets within 10-15 years of entire crawl data, but this explains the whole idea of how these text embeddings can help to make a search engine, especially if you are trying to do something like a product search for your website or some other data set that you have, which is not a couple of petabytes, but less in memory. While the data is syncing, let's take a look at our web application that I've done using Next.js and two custom files, which are the base sources of connecting to MongoDB to find the complete links and embeddings utility function, like connecting to Qdrant similarity search and vectorizing the given search query. The rest of the Next.js project is straightforward with Tailwind CSS. Like Google, it just has one search input and takes a default value from a given parameters and set that URL parameter over the page to reload, making it super easy to write Next.js server action to conduct the similarity search and bring back the results from the database without making complicated UI API calls. After around 2 weeks, I just gave up, thinking that I can have the entire internet vectorized on my laptop, and just started to test search results from what data I had already synced to my Qdrant database. The results are quite good compared to the amount of data I got, but I can see that one very important feature is missing, and now I understand why Google is still the king of search. The thing is that Qdrant conducts the similarity search with a basic vector space linking as expected. That's how they built it. Still, Google, on the other hand, has the logic of page index, which determines what users have to see, which course adds a ton of complexity to the process. But honestly, I'm happy with the existing results I got with this much of simple implementation, like within a couple of hours up and running, and then syncing just less than 1 million domain names, and I still get quite good results on performing a search with very fast response times on my laptop. This was an experiment with the larger project that I'm working on, and by just following those steps, you can have a pretty good search engine for your website or mobile application on top of your data, and that has less cost than the integration with Elasticsearch or Algolia paid services. And as you can see, that's very easy to build on top of your existing project with just a couple of hours and few lines of integrations. As always, the code is in the description. Thanks for tuning in. See you next time.